Thanks, Mike, for the introduction. I'm here to talk about my experience straddling both roles as a, you might call it corporate data scientist, also a volunteer data scientist. I want to get into the concept of ROI and maximizing ROI, but not the type of ROI that we are used to normally talking about, particularly in a business forum. I'm going to start with a quote. This is actually foreshadowed in the panel we just heard. And from this quote, I have a confession to make. I am a data scientist, and I spend most of my time thinking about how to make people click ads. Right? I just want to get that out there. In the interest of self-preservation, I'm not going to say that that sucks. But with self-awareness, I do realize that analytical skill is a pretty precious skill. And I also will admit that a lot of people with this skill are spending a lot of time focusing on financial bottom lines and not social bottom lines. Why does that happen? The salaries of a data scientist are good. They're not country club good. So money isn't the main motivating factor. The way I see it, and a lot of data scientists I know are primarily motivated by interesting problems. We are kind of a group of intellectuals, and we seek out fun problems to solve. It just so happens that companies with interesting problems to solve have a lot of data to solve those problems. They have infrastructures to solve those problems, tools to solve those problems, as well as a collaborative working environment. So what we end up with is intellectual capital, which we're assuming is the rare resource here, clustering with financial capital. And that leaves social organizations, charities, nonprofits, et cetera, falling short. But I ask, what if we could have both? And by both, I mean, what if we had a system or a corporate culture where data scientists can continue to think about ad prediction problems or building recommender systems, but also set their minds loose, solving some of the more interesting problems that exist in the nonprofit sphere? One way we could get there is just one basic realization. The same tools that I use to build an ad click prediction model are the same tool that someone else might use to build a recommender system can also be used to save lives, improve cities, or empower rural villages. I mean, just as a hammer can be used to build a bank, it could also be used to build a hospital. Data science is an incredibly transferable skill. So if you think about this from a corporate perspective, you've made your investment in learning how to build and deploy a new modeling system. You've built a data center. You've invested in installing all the tools, your Hadoop systems, whatever NoSQL database you have. All that investment is done. With a small additional investment, you could actually make a huge contribution to some charity of choice. This might sound like a crazy idea, but it's been done before. It's actually being done right now. Google Giving. It's one of Google's charity programs. I don't work for Google, so I haven't experienced this myself. But the goal of this program is to match the Googler skills with the nonprofit needs. And usually these skills represent programming or data science skills. And I underlined one part of this text, and this is from their website. They donate 20 hours of work time across the year of their employees to volunteer. When I first read that, you might think, wow, 20 hours, that's not a lot considering how much these organizations need. So I ask, is 20 hours enough? Well, I'm going to say absolutely it's enough. I think more is always better, absolutely. But I'm thinking more about how do we create a long-term sustainable version of this. And in my experience, 20 hours has actually been enough to make at least some impact. And here's where I introduce the actors of this story. Datakind has already been mentioned. That shaves 30 seconds off of my presentation. Also, Media6degrees, we are an advertising company. So I engaged with Datakind 9 or 12 months ago. I went to one of their hackathons. Hackathon was a great experience for basically rallying the troops and getting to know everybody. They introduced me to the New York City Parks Department. And after I left the hackathon somewhat unsatisfied because I got to work on this problem, I got my hands dirty, but then it was over, right? I went back to work the next day and I thought, well, the data wasn't exactly how I wanted it to be. I didn't get to implement the exact thing that I wanted to implement, and I knew I had the skills to work on the particular problem that they had. So I got back in touch with Datakind, and I said, let me stay involved. And the amount of work that I put into this project ended up being about 20 hours worth of non-consecutive time. And so I want to talk a little bit about that and focus on the impact that I was able to make. So at the beginning, most data scientists will relate. If you spend some time just thinking about the problem, really articulating what is it you're trying to solve, understanding if you're asking the right question, that's always one of the most important things to look at. So I spent a few hours doing that. This is what we were tasked with. This is a situation when a good tree turns bad. If you live here in New York City and you experienced Hurricane Sandy, this is probably a very, very familiar image to you. So what the particular problem that the Parks Department had was, can block pruning reduce future tree hazards? So let me define a few things first. Block pruning is a program that they have where they systematically send maintenance crews out to the various boroughs, and they just go around cutting down dead limbs, trimming excessive leaves, etc. So the hypothesis is that block pruning is a proactive way to reduce potential damage to trees during windy days or storms or even any random day. So these charts here show what a typical day looks like for what you might call a tree hazard. A tree hazard is when, like an emergency situation where a limb falls down or a tree falls down and it creates some sort of public safety issue. So this is a typical day. The other one shows what it looks like after a bad storm. And again, these are exactly where the maintenance crews had to be dispatched. Now, the goal of block pruning is to proactively come up with a system so that a aftermath of a bad storm looks more like a typical day. It's all about resource allocation as well as public safety improvement. So as a data scientist, I had to turn this and translate this into a problem that I could solve quantifiably. So the question we came up with is, can we quantify the effects that a New York City parks pruning program has on reducing future tree hazards? Now, if you're a statistician, and especially if you work in the ad industry, you might recognize that this is primarily a question of causality. It just so happens that causality is a question that we often ask in the ad prediction world. Did this ad drive someone to take some sort of action? So as a data scientist for an advertising company, I've become very well equipped and knowledgeable about the types of tools and the types of approaches we could use to solve these problems. So most people would agree that the gold standard in causal analysis is a controlled experiment. We learned some of the math behind that last night in one of the lightning talks. But the idea, for instance, in this example would be I randomly separate the blocks of New York City into different groups, one test, one control. The control group, I just let it be, let it grow to its heart content. The test group, I'll prune it. And then let's say I wait 6 months to a year and I measure within each group what was the average number of accidents that might have happened or tree hazards that occurred. And so the difference between that would be the causal effect. So again, that's a pretty standard approach. A lot of businesses do that, but here we have a situation where controlled experiment is very difficult. For one, there's ethical concerns. If you are to do a controlled experiment on city blocks, that means you're intentionally letting dangerous conditions exist for the purpose of science. So there's actually a precedent for this in the medical world, is you can't not treat someone who is sick. So in these types of situations where health and public safety are an issue, you need an alternative. Another reason is you can't A/B test the path. It's kind of obvious. So the Parks Department came to me with 15 years worth of data. So it's not like I could go back in time and take that data and come up with an A/B test. But fortunately, there are observational methods that essentially allow you to statistically recreate an A/B test. I would say these are more difficult, and even in the statistics community, there tends to be some controversy as to can you fully interpret it as a causal estimate, but that debate aside, at least it's directionally in the right where you want to be. So the next step was, I don't know how many data scientists actually enjoy this phase of their work, but it's the data munging, the joining and exploring. And if there's one thing we learned about city and government data is it's not fun to work with. We heard from the 911 data sets and the prior talk that, government organizations work in Excel spreadsheets. So I was given multiple Excel spreadsheets of 50 megabytes each that I had to deal with, join, clean, et cetera, et cetera. And then after doing that, I found that there were some problems. And then my contacts over there looked, and yep, there was an issue pulling it. So I had to rinse, repeat, and do the whole thing over again. So, nonetheless, I got through it, mostly on a plane to California. So here was the data that we were dealing with. Again, I am working on a causal estimation problem. So I had to fit the data within the framework or the structured framework of causal data. So I don't know if anybody has a mental picture of the trees that are in front of their apartment or in Central Park, but the New York City Parks Department actually has a map and a census of every tree in this city. They call it the urban forest, and they don't go as far as giving every tree a pet name, but at least it has kind of some descriptive information about it as well as the location. So they gave this data to me. This is their tree census data, and from this tree census data, I had to roll everything down to the fundamental unit of analysis, which was a city block. So with that, I could create features like how many trees are on that block, how many trees by type, how many trees by size, et cetera. They also have a data set which contains the history of every maintenance work, every bit of maintenance work that has ever been done in the last 15 years. So from there, I could construct more features. I could say, how many accidents happened to trees the following year, or the previous year, the year before that, also in the current year, and the next year. And so the two data points that I need to point out is, one is the treatment, and the question here is about the effect of block pruning. So that's what we would call the treatment. And it was that block pruned or not in a given year? Next is the outcome, which is, the way we defined it, is the number of hazardous work orders in the following year. And this is important. This goes back to answering the right question. Is this something that the Parks Department would accept as an acceptable outcome? And it was. So next, the insight. Another 8 hours of my time. The key with observational data analysis and causal questions is to consider this phenomenon called confounding. When you have a well-designed controlled experiment, you actually you eliminate confounding because both groups are statistically identical, or at least you hope they are. So in observational data, when you just kind of let the cards fall as they are, you get this issue. And the definition of confounding is you have a feature or variable that affects both the outcome and the likelihood of treatment. So in this case, one example of confounding might be the number of trees on a block. So if you think about it, the more trees there are on a block, the more likelihood one of them is going to be overgrown and go bad. The other part is, how does the number of trees affect the likelihood of treatment? The Parks Department does their best to ensure that the block pruning is done on a random routine, but it's also at the discretion of the maintenance crew to, as they're traveling to and from their work locations, to stop and prune any tree or any block that looks like it needs it. So a block with a higher density is more likely to get the attention of the maintenance crew. And this is something that I could test and quantify and is actually able to prove that there is definitely confounding. So here's where the only math that I'm going to show here. And the point here is not to understand what is going on in this slide. It's just to point out that this is a tool. This equation is a tool. It's called double robust causal estimation. And essentially it creates a combination of two methods that are generally accepted to be good, but can fail under certain circumstances. And the double robustness is it reweights which of these methods gets to contribute to that particular observation. The point here, though, is that this took me a while to digest, but I suffered through it, and I learned this on the job. I learned this actually by building a product where I'm trying to understand the effect of advertising on people. And I spent way more than 20 hours learning how to use this, learning what the pitfalls are, and learning how to interpret it than I did on this particular problem. So here I am, fully equipped with knowledge and skills that in a very short period of time, I could turn around and solve this problem. And that goes back to my original point. With little additional investment, I was able to do this particular project. So here are some results. According to this chart, and this is just if you analyze the data without doing any sort of confounding adjustment, you would see that the blocks that were pruned had more hazardous conditions than the blocks were not pruned. So the y-axis is the number of accidents, you might call it, in the following year. So the interpretation of this is that by proactively pruning New York City blocks, we're making our city a worse place to live. This is not something I wanted to go back and report to the Parks Department. It's also a reason why you need to have someone trained in this sort of analysis to answer these types of questions, because a naive data scientist could easily go in there and just draw these conclusions and kind of wreak havoc in the organization. So fortunately, these were wrong. When you applied this double robust method, you get a very different picture. And so I have two charts here. The darker one shows a reduction in accidents by 13%. So this is the interpretation of this is if you were to just randomly select a block, or rather prune every single block in the city, you would expect a 13% reduction in tree hazards. The green bars show the effect on the actual group that was treated. So within that group, and again, this was not maybe consciously targeted, but it definitely was a targeted group, generally targeted as more at risk, you got an even bigger effect. So there's a big implication to that, which I'll get into. But one thing to note is when I set this program up, I let it run overnight, I got back in the morning, and it took a while because I did 1,000 bootstrap examples so I could get confidence intervals. I got this number 22%. I had no idea what it meant. Again, this is not my domain. But when I brought it back to the Parks Department, I wouldn't say their jaw dropped, but they were really thrilled with this. And they were able to bring it back to the organization. And this was one of the first times someone has put empirical proof that this long-standing hypothesis in the parks community, or the urban forestry management community, had an effect. And so this was kind of, some bell went off. And they were really happy with this. So another thing I was able to establish is that if you do pruning selectively, and that is, you can actually find areas that intelligently target blocks that are at risk. If you only have a minimum budget to invest in the pruning program, you can actually maximize the return on that particular budget. And, and that's like 13% versus a 22% reduction. So beyond trees, I asked the community here, and particularly decision makers, corporations and companies, generally for profit, what can we do to make this sort of program more sustainable and scalable? Now, there's certainly matching services. We just heard from Code for America. We also got introduced to Datakind. So these these companies or these organizations are necessary for this sort of thing to happen, because they're able to aggregate a community of data scientists and match them with the appropriate organizations that need them. We also need to motivate data scientists. I don't think that's actually a difficult thing to do. With Datakind doing what they're doing, they can actually come up with a list of here's an organization, here's the data, here's a problem. It doesn't take long to scan through 10 of them and find a really cool thing to work on. The last part, though, is motivating corporations. And this relates back to the data scientist, because doing all this takes time. Even 20, 24 hours, you still have to decide, is it going to be on your weekend? Is it going to be evening? I don't know if you could sustainably expect everybody to have a full-time job and then spend 4 hours a night, once a week, doing this sort of thing as well. So in my experience, I was able to actually get my company to kind of sponsor me and let me do this on our company servers using company intellectual property and, most importantly, company time. And all it took was 20 hours. And that's why I say 20 hours is most certainly enough. So how do we, and this is kind of an open-ended question, how do we motivate the corporate decision makers to want to be involved in this sort of thing? And I don't necessarily have an answer for that, but I want to leave everybody thinking about that. So I'm going to end and say, a small donation of your time, you could certainly have your clicks and eat them too. So thank you.